Okay, good morning everyone. Welcome to UCR and Electrical and Computer Engineering Department. My name is Hamed Mohsenian Rad. I'm an Associate Professor of Electrical Engineering and the Graduate Advisor. So I guess you already had a presentation with the Dean of the Graduate Division. I try to mainly talk about the department, the ECE department. So we have two programs within the two graduate programs within the ECE department, and I know that kind of half and half you guys are interested in master's and PhD. I'm going to go through our master's program first, and then PhD program. And please stop me if you have questions. So for our master's program, it is generally a 1 or 2 years program, depending on which track you take, and I'm going to explain it in one of the coming slides. So you need to take at least 36 units of ECE, our department's basically courses. But that number, that exact number, depends on whether you end up doing only courses or you also do thesis, right? That's optional. When it comes to PhD, that's not an optional. That's basically thesis is one of the major aspects of your graduate studies. But for master's students, you can take either of the options, right? So, and based on that, you will end up basically being plan one master students, which is thesis based, or plan two, which is essentially exam based, right? And this picture is from one of our award ceremonies. I'm going to show you basically what kind of awards we give, which could be of interest to you later on. So looking at the two options that I mentioned earlier, under the thesis option, you will end up taking 12 units for research. So why would you do thesis? Essentially, if you're not sure whether you want to do PhD and you wanted to do master's first, but kind of, in your mind, you're thinking, maybe I should end up doing PhD. This is a great opportunity to do some sort of research work and basically get an idea what research means in this field, and if you're interested in it, continue towards that path. That's one reason for you to do thesis. The other reason is that essentially it builds up an expertise for you, because at the end of the day, when you graduate, you say that, okay, this is the area that I kind of narrowed down and worked on, and maybe wrote a paper. Not necessary. It's not a requirement for master's students to end up writing a paper. But essentially, when you take courses, you still have an area of kind of focused area. But when you have a thesis, you have a particular title for your thesis. So that means you have something extra to put on your CV and say that, okay, this is the area that I spent a couple of months working on. This is my expertise, right? So a thesis must be submitted and defended. So there will be a committee, there will be a thesis advisor. You will present your thesis and findings to that committee, and they grade it. Essentially, you will have to pass. And the typical time to degree is 2 years, partly because it's not just courses, and you have to do some research work with the supervisor, and it may take some time to basically finish that work. Then the other option, which is basically mostly on the course and exam, you will take several courses, right? You don't take the 12 units of research, because that's not your focus. And then, based on those courses, you have to take an exam. Essentially, the final step in the thesis option is writing the thesis and defending. And the final step in the course-based option is to pass the exam, right? Bunch of courses, 5 courses, basically. And because of that, the time to degree is 1 year. It's faster because you do your courses, and it is manageable to take all of them in 1 year and graduate, and you're done, right? It depends on what is it that you're trying to achieve. Any questions so far, especially master's students? Yes, go ahead. How many units do you take per course semester? How many units per? So we have 12, 13 with the curriculum, which colloquium means, there's a seminar every week from professors coming from different schools, right? So that you just get a general idea about electrical engineering, because you sit in every new seminar completely unrelated to another seminar from the previous week. So it gives you a broad understanding of the field, because we do invite them to come for collaboration and things like that, but they also give a presentation. So that's the 1 unit out of the 13. Then the other is 12, essentially, three courses, right? And those 3 courses could be all actual courses, or they could be research units, depending on what is it that you're trying to do. So that, as you can see, basically it is manageable to finish 36 within 1 year. For the course-based option. So out of that, if you want to go for research, then you can instead up to 12 take research units. For the exam is for the course-based, which is 36 units overall, but out of them only 5 courses. You pick which courses you want to basically take the exam on. There will be a package of 5 courses, and you will take the exam for those 5 courses. You had a question? Let me make sure that I understood your question. You're asking whether this is something that you have to decide right now or along the way? Is that the question? No. Oh, it is mentioned which one it is. Do you?
So there's 2 ways that you get it.
And the certificate, degree certificate.
Will say it.
Yeah. Yes. Flexibility. So I believe it is a full-time student position, basically, right? It is not part-time. So, I mean, it is okay to work. I even had PhD students that work, right? But the thing is, this is a full-time study. For your classes, you have to attend them, right? There's no way around it. But let's say for the research units, there is no class. You work with an advisor, right? And when you end up setting, scheduling your meetings and things like that, obviously then it will be between you and the advisor. And usually professors are flexible on that, right? But we're talking about only the research units. For the actual classes, you have to attend because it's a full-time study, right? Anything else? Okay. So on the comprehensive exam, as I said, there will be 5, we call it 5 problems, but basically you pick 5 courses. And the instructor of that course is going to give the questions. Typically the same instructor that taught the course in that year, right? So that means pretty much the same instructor that you worked with. Some instructors give only 1 question, some give 2. So in a sense, it's basically 5 courses, whatever number of questions that the instructors for those 5 courses give you. But your choice of 5 courses. Basically, at the time of each exam, the instructors get an email from Kim telling them that, okay, like 5 students picked your course for the exam, and then give us the questions, and then they grade it. So exam areas, we have 3 broad areas in the department: nanomaterials and devices, signal systems and machine intelligence, and VLSI circuits and systems, right? So ultimately, you have to decide which one is your area, right? And if you think about it, these are very kind of separate areas. Later on, you're going to see MS Teams and things like that. They're not more like branches, and then some of them may have slight overlap, but these 3 are practically separate, right? So you have to decide, okay, which one is really your area. So when it's not like something that you have to decide right now, but by the time that you enroll and take courses, you will end up taking courses, for example, in the systems and machine intelligence area, which are going to be very different from the nanomaterials area courses, right? And again, just one more note, yes, you can take another course from a different area just for the fun of it and then to expose yourself to that field. But when you get to the point of exam, you have to pick what is your area, take 5 courses within that area, right? And then there is a new rule we passed it last year, which is actually good for the students. you can waive up to 3 courses, exams for up to 3 courses, if you take A or A+ in that course. So what does that mean? That means you go through the courses during the quarters, and you end up getting, let's say, all A+. So that means you will end up only taking 2 exams, two courses for the exams in the end, because you already did a good job. So there's no need to take the exam for that course. And we didn't have it previously. We had it only for PhD students. Now we extended it also to the master's students, but partially. For PhD students, I'm going to cover it in a minute. You can take all 5 courses waived. Essentially, some of our really good students, PhD students, they will end up not taking any exam. But I haven't talked about PhD students yet. Just wanted to do this distinction. Anyways, going back to master's students, you have 5 courses to pick for the exam. It should be within one area. But then if you got A or A+ in quite a few of your courses, or whatever number of courses, you can pick them for your exam, but you don't take the exam because you got A or A+. So that means it reduces the workload for that particular exam, right? And so another note here, you will have a second chance for the exam. So that means you will have a chance to fail. Essentially, it's going to give you 3 chances. The first one is get an A or A+. That will waive that. Then the second one is the actual exam. You may fail the first time, and I'm going to show you the statistics. And then there will be another chance, and basically that's it, right? Again, any question? I don't have many slides, so I try to stop at every slide, and because this is the chance for you guys to decide basically what is it that you want to do. So it's a broad area. So all the systems and kind of intelligent systems topics are within that area. It includes control engineering, it includes power engineering, it includes signals and systems, it includes communications. All of the more math-oriented topics are within signal systems and machine intelligence. RF? It depends on what is it that you're trying to do. If, I mean, you can talk to different professors, basically get into the exact niche area that you have interest in, and they will tell you. But broadly speaking, if it is more on the hardware side, if it basically you're building new hardware, right, and things like that, probably you're more on this area. But if you are talking about, okay, on top of that hardware, I'm developing new software technologies like new algorithms, or new signal processing methodologies are on that RF device, then you are in the, then you are more in this area, right? Anything else? Okay. So these are the MS theme areas that is less formal, and as you can see, there are more branches. But ultimately, each of them you can somehow match to one of the areas that you saw earlier. So quickly going through these areas, because ultimately this is something that you want to focus on, right? When you get your master's, you will be, for example, within the signal systems and machine intelligence area, but you may do, I don't know why I'm doing this, but you may do smart grid and power systems, right? Or you may do communications, or you may do robotics and computer vision. They're very different, right? Ultimately, they're all part of that signal systems and machine intelligence, right? But from different aspects. So for example, here we just introduced a new course on 5G, the new communication technologies, wireless, all sorts of aspects related to that, and to some extent even networking protocols and things like that. Obviously, in this area, which is actually my area, power systems is more on renewable energy, smart grid technologies. We have faculty working on electric vehicles, right? Kind of on the power system side. And then robotics and computer vision, which is a very cool area, emerging area. And we have a couple of new faculty hires in this area. Like computer vision, essentially, in a sense, the application is broad. Believe it or not, even in this area we use that, right? But probably the closest application area is robotics. And there are also some level of interactions and collaborations with the mechanical engineering department. But like here, we are more focused on the brain of the robot, not the joints and things like that, right? So I guess I covered these three. And then these two are also closely related and kind of converge to the first exam area that I covered earlier. These are material and devices for electrical engineering, right? So for example, let's say new technologies for batteries, lithium-ion batteries, right? The most recent Nobel Prize was in that area. Or other technologies for battery. We have faculty members in our department that work on developing more sustainable choices, like instead of using lithium, for example, or for battery technologies, or let's say solar cells, new materials for solar cells, right? So, and then the different ways of fabrication, the optoelectronic aspects, they're going to be in these two areas, very hardware-oriented, compared to like the other three that are more at the systems level. And then this area, embedded in real-time systems, which is the VLSI design, computer architecture, and computer engineering. Our computer engineering faculty are here. As you know, our computer engineering program is kind of joint between ECE and CS, right? But this is essentially the highest projection level of computer engineering to our department, right? So, and then in several other fields, for example, Internet of Things, we all use that. We use it in our power systems group. And like, in terms of applications, the data that they collect or the commands that we send, but there are some other people that actually develop those devices, or you mentioned RF, I guess, earlier. So they're all related. So that means even among these areas, we have collaborations and interactions, but ultimately, you should decide, and we have kind of a list of suggested courses for each one, meaning that by default, we give you a plan that, okay, if you just want to stick to one of these and then that's it, that's all what you want, just simply follow that plan. But then you will have choices to discuss with the advisor and things like that to slightly change it to make it even more suitable for your particular goals. Yes? Right, we have courses that are cross-listed with the CS department, right? Let's say, to give you a few examples, like this area has many cross-listed. So that means you take the EE version, they take the CS version, but ultimately it's the same class, right? Because it's cross-listed. And then in this area, we have cross-listing with the mechanical engineering department. I mentioned that. And then in this area, in these two areas, we have cross-listing with the MSc, Material Science and Engineering program, right? So essentially the same course, but the goal is that we coordinate the two departments, because sometimes our faculty teach that course, sometimes even their faculty teach that course. Every time that it is offered, both departments can take the course, so that gives you some more options, right? But they're essentially cross-listed. Any other question? So, okay, let's move on and talk about our PhD program, right? It is kind of an extension of the research track for master's students, right? Remember, I told you that if you take that track, you will end up writing a master's thesis. So here, you will end up writing a PhD dissertation. And novel and independent research. So that means the idea is that you have to push the boundary of your field. And this is serious. You're going to basically start taking courses. You're going to pick a topic, you work with your advisor, figure out what is the state of the art, and then try to push that boundary further. And then ultimately, you will end up publishing papers. And that's an important aspect of your work, right? So we expect, for example, let's say 3 IEEE transaction papers for our students at the end of the PhD. So the milestones, there are a couple of them that gives you an idea. So pass PhD preliminary exam, normally at the end of the first year. Essentially, first year focus on courses. But many students may still take some courses later on because you may meet the requirement of the degree in terms of the courses. But then later on, when you are doing your thesis, it turns out that you need another course. So occasionally in your third year, even fourth year, you may end up taking courses, right? But typically, at least with respect to the bulk of your courses for the degree requirement, you focus on courses in the first year, take them out of the way, build up your basic background. And then in the second year, you pass the oral qualifying exam, which is essentially about your research. So you took several courses with direct advice from your PhD advisor so that you can focus on what you need to learn in order to start doing research in your field. And then you spend another year essentially kind of putting together some preliminary results from your research. Often we expect like at least a paper by the end of the second year, which is essentially the base of your presentation for oral qualifying exam, right? So second year, you do a lot of work on research, start clearly identifying what is it that you're trying to do, right? At least what are the goals, right? Having a good understanding of the key challenges, right? And then you defend your qualifying exam. For that, you need to form a committee. Your PhD advisor is going to be the chair of that committee. There will be 5 people. One of them will be an external member. And then you defend and go through. And then finally, defend your PhD thesis, which is the final stage, a stage of your study. Once you do that, you're done. You graduate, right? And typically, it takes 4 or 5 years to wrap up the whole thing and then defend your thesis. And again, it's going to be a committee. Again, your PhD advisor is the chair of that committee, and they should basically approve it. So that's the path. And in terms of the courses, you have to take 9 graduate courses, right? I don't think that we have included it, but you have up to 2 courses to kind of bring from your master's if you already took a master's, right? Even somewhere else. So if you have equivalent course, it goes through a process you have to submit. So that means you reduce the number of courses that you will have to take if you already took some graduate courses somewhere else. But it's a formal process to go through. And then for the preliminary exam, remember I mentioned that if you get A or A plus for masters, you can waive up to 3. Here you can waive up to 5. So that means some of our students, the really good ones, they actually don't even take this exam, right? Because they got many courses with A or A plus, right? But we also have some students that end up taking all 5. That happens, right? Tough courses. So, okay. Any question on this slide? So kind of related, this is the statistics just to get an idea. Student success in the comprehensive exam and then preliminary exam for PhD students. So pass in the first attempt. Our PhD students very dominantly pass on the first attempt, right? And part of it is because they have more courses to waive, right? And to be honest, I think this one of the reasons for difference is that waiving courses for master's students, we did it only recently. So up to last year, they had to actually take 5 courses as an exam all at the same time, regardless of how they managed to do the courses before. So obviously, with 5 courses, that's a bit tough. And that's one of the reasons that you try to waive. If you did a good job already during the during the quarter, when you took the course, then we can reduce your workload in that exam. So anyways, this is the case of passing the first attempt, then the passing in the second attempt, and then occasionally we had cases that the student failed. But this is basically the process. Just wanted to give you an idea. Yes? No. The 2 exams, remember you have 2 choices. They are twice a year. I don't know if I have the dates. So one is June, right? And the other one, I believe, is December. So that means, so typically you come in, let's say in fall. By the end of the year, that's the best time to take that exam and get it done, which is June, which is at the end of the quarter, right? Then if you didn't pass, then you will wait, you have to enroll in another quarter, and then you will do it in the second attempt. But as you can see, that doesn't happen often, right? Especially now that we're going to have that waiver for A or A+ courses. Now, so for PhD students, I remember I talked about awards and stuff. So because their focus is on research, obviously we have a lot of emphasis on research achievements. What part of it is, for example, getting best paper awards in different conferences in the field, things like that. And we always have, like every year, a couple of our students in different fields get the best paper awards in the conferences in their fields. But we also value our teaching assistants, right? So graduate students, especially PhD students, basically, occasionally masters, but the priorities for our PhD students, they are offered, as part of their package, they are always offered at least one TA position. And part of it is just to help, and I'm going to explain the financial side of it. But the other part is that ultimately, as a PhD student, when you graduate, you should be exposed into the teaching experience and also the overall presentation aspect, right? So, and we value, again, our outstanding teaching assistants. These are the most recent awards. And we do it every year, essentially based on the evaluations from the students, for the most part, right? But then there is a committee for all of the awards that we give. There is a committee, and then it goes through a fair process. So let me cover this slide, and I believe there will be some questions on this one. Now, for PhD students, one thing that is not entirely unique, but not very usual among universities, we basically fund all of our PhD students, meaning that every PhD student in our department is funded, meaning that we pay the tuition and we pay for a stipend for the student to work on projects. So where do we get the money? We get the money from our projects, right? The projects come from all sorts of sources. Many of them are from state and federal research agencies, right? So for example, in my field of research, we get a lot of projects from Department of Energy, US Department of Energy, California Energy Commission, National Science Foundation, right? And then there are some projects from the industry that it could be directly from industry or with industry, kind of collaboration with industry when, again, the money ultimately comes from government and things like that. So that means when you come in, you work with the professor that has these projects, these grants, you get paid. Part of your job is to help deliver the project, right? And then the rest of your job is take courses, write, work on papers, and occasionally be a TA, right? So that's an important part. Again, if you're applying for a PhD program, you have to contact your intended professor, right? Because keep in mind, because we fund every PhD student, and that funding ultimately comes from the faculty members, there should be a faculty member that champions for your hire, right? They say that, okay, I have this project, and it seems that you are a very good fit to this project, so they hire you, and then they recommend for admission. Occasionally, if we see a very good student that is not kind of matched with any professor, we may still hire them. We may still give them admission, give them some financial support from the department's fund at the beginning, because we believe that ultimately, when they come and take courses and they interact with the professors, there's a very good chance that the professors take them. But the majority of the PhD students that we bring in are essentially coming in to join a project and work with a particular professor. And typically, our faculty members supervise between 5 to 8, 9 PhD students, and they're all funded, right? So because a PhD student comes with all funded, essentially, setup, that means they're linked to projects. That means they're linked to the research areas in our department, right? And then if you go to the department website, you see that for every research area, you see the list of faculty members. Every faculty member is at least in one area, right? But many faculty members are in two areas, like primary, secondary. Like for example, I'm in the power systems area and also in the communications and signal processing area. Primary focus, secondary focus. And even that gives you an idea, okay, what is it that this guy is doing, right? Like the combination of the areas. Like intelligence systems, many faculty work in the area of intelligence systems. Some of them develop methods, right? Some of them use the methods in this field for certain applications. And for those guys, essentially their primary area is something else, but they also work in the intelligence systems area. So in terms of the, the topics, I already mentioned that they're pretty much kind of probably not exact one-to-one mapping, but they're quite related to the MS themes that I covered earlier. But this is really in the research areas, and really we have a faculty allocation to these fields. So that's the point. Any question on this, like on the stuff that I covered in these two slides? Again, for the PhD students, or for the master's students that have kind of some tendency to also explore PhD. Okay, so then probably to give you a reason to explore PhD is average salaries of 2018 graduates, right? And obviously you see a big difference. So it's a good investment, but this is also related to your interest. Is this like research and exploring new ideas and things like that? Is this something that you want to try? But you see that there is difference. And our PhD students, I have seen even higher, like in one case in my group, 170,000 was the starting salary for the PhD graduate. Okay, and different areas that people have gone to. And again, if you think about any of these like logos that you see, you can guess which area ended up going to, for example, I don't know, Google, right? Or Southern California Edison is a power systems area, right? So, any question? Then, I guess one obvious question is how can you apply? There's a link and there's a deadline, but as I said, for PhD students, part of it is to contact faculty members, right? So go to the website, look at the 6 research areas that I told you, see which one is the one that you have interest in, look at the faculty members in that area, look at their publications, projects, where the students ended up going, things like that, and then start the process to talk to them. And obviously, both of our master's and PhD programs are quite competitive, especially when they're supporting you all the way through tuition and stipend and everything, right? For example, when you work on a research project, you write a paper which is accepted in a conference. Obviously, your advisor covers the cost so that you can attend the conference. Our students go to internship. Pretty much all of our master's students end up going to internship towards the end of their graduation. They get some help from our faculty, but for our PhD students, they get a lot of help from our faculty to go to various internships. And I would say every one of our PhD students, ultimately before graduation, they go at least one internship somewhere, right, to experience the outside environment a bit, right? So I guess that's it for my presentation. You asked a couple of questions during the presentation, but if there is anything else that you want to discuss, yes.
So can you show us the summer research internship program for the undergraduate students? But you guys are doing research in computational imaging. So is there any research opportunity for grad students, international grad students?
International graduate students?
For summer.
So are you saying that you are doing, let's say, PhD somewhere else, but you...
I'm doing MS somewhere else, but I want to do a summer research in computational imaging.
So what you are saying is that essentially you want a summer research position, even if you are not a student at UCR, right? Occasionally, I think our professors do that, meaning that, okay, if they need somebody, again, because of the projects. Because projects have deliverables, have deadlines, and all of those things. And for whatever reasons, their students are not enough. Part of the reasons that can happen, and I had the experience, the student wanted to do internship, so he left, but then somebody had to take care of the project while he's away during the internship. So those cases may bring opportunities for these kind of applicants that are not really our core students. We're not working with them directly, but maybe there's a position. I don't know how likely that chance is, but you can contact different professors and see what happens. I believe in form of like visiting student positions and things like that, we occasionally had cases that we brought the student and paid them during that visit. Anything else? Okay, very good. I hope you enjoy the rest of this day. Thank you.